Well, hello and welcome to our next episode of the DevDen Hangout. I'm Grace Francisco, one of your hosts for today. I am the head of developer advocacy at Atlassian. I have with me a team of experts today. I have Ian Buchanan out of Munich.
Hello.
There's Ian. And Nicola Paolucci in Amsterdam.
Hello there.
And then Steve Smith, also in Amsterdam.
Hello.
And then Tim Patterson out of San Francisco.
Hey, folks.
All right. Today we've got a whole bunch of great topics to cover, starting with Nicola. Nicola, tell us about the new logging process that we're following.
Yes, I find this very interesting to talk about and tell and share this really cool thing we're doing, which is recently we have restructured and adopted a different model, a different process to publish our blog. So we actually have transitioned all our technical content and the intention of writing technical content in the future to a new blog at developer.atlassian.com/blog. And that is a completely new technology stack. And it's much more developer-friendly than our previous process. And before we still do have a quite sizable and very performing, very advanced WordPress deployment for our, say, corporate blog, which is blogs.atlassian.com. And we wanted something a bit more, tailored at developers, and where we can share our own hacks and our own findings, in the tech sphere. So we created our own, basically, and what we picked was so we use a static site generator, which is fancy thing to do nowadays. It is a very cool way where you can have a super performing blog system that serves only static files. And so the one that we chose after a review has been based on Node.js, and it's called the Lineman.js. And obviously, to store actually the sources of our articles, we use Bitbucket. And we're big fans of like simple static text files for our articles, so we use Markdown. And the only thing that we needed to track some dynamic content and interaction with our readers is like a way to track comments, and for those we use and currently discuss. So, but more than the tech stack, what I wanted to tell you is our process. So obviously we use Git and pull requests to manage and publish our blog. So the way we work is this. Anything that gets any branch that gets merged to master goes directly to production. So, and each branch might contain one article. And the next stage of our blog, so the next post or the next few posts that are going to go live, are branched off develop, which is like, say, work in progress branch. And so when I want to write a new article, I create a new branch of develop. I name it with a special prefix, which is blog, so blog / and then the short slug for the article name. And there I write my own Markdown files. When I'm ready to share this work in progress with my colleagues, I open a pull request, and we have a review that can happen very nicely on Bitbucket, and we have a live preview of what's happening on our staging site, and we talk a bit more about this a bit later. And after that process works out, and we fix what we need to fix, and everybody's happy about it. And we generally want to have at least 2 approvals for each article, and then we go through also a grammar review at the end. And so after that, then we merge it to master, and it goes live. So that's very roughly, very quickly the process. And one interesting bit that came up in hacking this solution, in like developing this solution, was how we show on staging more than just one article at a time. So initially we were like everything that was merged to develop was going to staging, but then sometimes you want to change the date of things. So you need to rework and move when articles are going to go live. So we actually came up with a very clever way to do it, and Tim actually wrote an article about it. So maybe Tim, you want to explain a little bit this advanced technique that we use for our staging server? I think people will find it very interesting.
Oh yeah, for sure, Nicola. Yeah, so as Nicola was saying, like we have this amazing process now for staging our blogs and well, and getting them through into production. The only problem is like because we've built this awesome process, all of the other developers at Atlassian are very keen to start blogging as well, because it beats the hell out of WordPress, which was what we were using before. And one of the problems of having this increased uptake in authors is that it means that multiple people are developing their own blogs and trying to get them onto the staging server at the same time. And this meant that we'd have different individual feature branches, as Nicola mentioned, each blog is being developed on its own branch, trying to be staged at the same time. And we're basically stomping each other's changes. In fact, I can probably give you a little demo of, well, to illustrate that. So I'm just going to try and share my screen here. Can you see my terminal there?
Yep.
Cool. Okay, fantastic. So what I'm going to do is run lineman, which is the little static site generator that Nicola was talking about, so we can actually see a local copy of our blog, actually, and that's probably means I'm going to need to share more than just my terminal, so give me one moment. We'll share the entire screen. There we go. All right, so lineman's pretty quick to run up, and we're running just like a little local HTTP server, which is going to be serving our static content. And we're currently running from a branch called a beta pull request, which is a blog that was published last Thursday. So if I open up my browser and hit localhost 8000, you can see our developer site. And if I go to the latest blog posts, you can see the most recent blog post is a beta pull request because we're running from this branch, which was actually merged into developer last Thursday, but it'll do well enough for these demonstrative purposes. But if I change to a different branch, so let's, oops, there are a few too many branches. Let's check out getting to know IOJS, which is another blog that was published last Friday, and then refresh our page. You'll see that the latest blog post is getting to know IOJS, but that other blog post that we were just looking at, a beta pull request, has disappeared. And if we flick back to a beta pull request again, I'm going to use this cool little command, git checkout dash. If you haven't seen this before, it's pretty cool. It'll go back to the last branch that you were working on. So it's kind of a nice way to quickly switch context if you need to be working on a different branch. But if I go back and refresh, you'll see that a beta pull request is back at the top of the list. And this is effectively what was happening on our staging server, because basically we'd have multiple people developing the same branch, or developing their articles, pushing them to the staging server, and then our continuous integration and continuous deployment job would be deploying that latest branch on top of it. So what we did is we built a little tool that solves that problem. So what we did is we kind of considered the different solutions. I mean, I guess there's a few obvious ones. The first is that we could have one staging server per branch. The problem is with that is that it can get relatively expensive, because if you have 10 different branches on the go at the same time, you're going to end up with 10 different staging servers. The second solution that I came up with was could just continually rebase my blog branch and keep pushing that to the server, so my article is always deployed and stomping over the other authors. That obviously is not a great idea in a team context, and directly violates one of our Atlassian values, which is play as a team. So the third solution we came up with was perhaps there's a better way we can solve this using Git. Now, Git has a bunch of different merge strategies, and one of them is a very special merge strategy called the octopus merge that allows you to merge multiple branch heads together. Well, sorry, more than 2 branch heads together. So we had this theory that we could potentially merge all of the different articles that were ready to be published or ready to be reviewed into the same hedge, and then deploy that merge result to the server instead of just deploying a single branch head. So I might just share my screen again. I can give you a little example of what that looks like. Sorry, one moment. Can you see my terminal again?
Yes.
Okay, cool. So I've got a little empty repository. It's just got one commit in it, and it's got this little octopus building script. Basically what this is going to do is generate 8 different branches, each with 3 different commits on them. So if I go build octopus.sh, you can see it's generated a whole bunch of different commits, and we now have 8 leg branches, well, obviously because it's an octopus merge. So the way that we do an octopus merge is simply running git merge, and then typing in the names of the branches that we want to merge. So it's just like a regular merge. You just give it more than just the additional head. Oops. Bear with me for 1 second. And the other thing I'm going to do is use the no fast forward strategy. So we're going to create a new merge commit. So this will be kind of the body of the octopus, if you will. And now, well, so that's created a merge commit with 8 different parents. And just to illustrate that, I'll run git log. And you can see we have this quite attractive looking octopus thing going on with our merge commit at the top. And then every single branch being merged into that. And this is effectively what we wanted to do with our blog site, because we wanted to have all of the different commits that other people had been independently developing and then merge them all together. But there were a couple of special constraints that meant we couldn't just use a merge commit per se, an octopus merge per se. The first kind of constraint on us was that this merge, because it's going to be running on a Bamboo server, so basically running non-interactively, it can never, ever fail with conflicts, because if it fails with conflicts, that means that it's not going to be able to deploy because it'll have this conflicted working copy, and that's not something that's appropriate to deploy to our staging server. So that basically meant that our Octopus merge would have to be run in such a way that it would never conflict. The second thing that we needed to do is to make sure that the changes on that branch the changes that end up in that deployment are only static changes, so actual blog content. Because that repository contains all of the actual site itself, so all of the logic for building that kind of attractive front page. If any of that stuff changes, we don't want to automatically merge that because there's a chance to get logical conflicts. We only actually want to deploy individual article content. And the third thing that we wanted to do is allow you to not stage your content if you didn't feel like it was ready for review. So we didn't want to just be taking every single branch from the repository, bundling it all together, and then pushing out to the server, because potentially there's some sensitive content, or potentially you're not ready for it, your things to be reviewed just yet. So what that meant is we built, instead of just using an octopus merge and putting that into our Bamboo script, we decided to build a new little tool called git merge distinct. So git merge distinct is it's basically a wrapper around an octopus merge, and I can probably just give you another quick demonstration on how that works. So let me just share my screen again. Can you see my terminal again?
Yep.
Cool, okay. So I'm going to pop back to that command line that we were looking at before. I can probably make my terminal a little bit bigger here. There we go. So I'm going to check out develop. Just have a quick look at branches we've got here. So we've got develop, and then we've got 2 outstanding blogs. Those 2 we're looking at before: a better pull request and getting to know IOJS. So what we're going to do is run git merge distinct, so we don't need the hyphen. And the first thing I'm going to do is say that we only want to include branches that have changed paths underneath app/posts. So what this is going to do is it means it's only going to allow branches to be merged into this deployment artifact that have content that's changed under app/posts. If the author of that branch has changed some content outside of that, so possibly some dynamic content which is used to as part of the core functionality of the site, then that won't be included in the actual branch that's going to be deployed. And the second thing I'm going to do is specify an additional qualifier specifying which branches I want to be merged. And in this case, it's going to be anything namespaced under blog/something. So basically, this means that only these 2 blog/ articles are going to be deployed. And this other branch, series/continuous integration, which, because it doesn't start with a blog, is going to be considered private and not something which we want to deploy. So when we run this command, fingers crossed, excellent. Comes out with the output merged 3 parents. And basically it's merged develop, which is the branch we were on originally, and then these 2 blogs, which is exactly what we're hoping for. And now, because our lineman server is running in the background, if we just pop back over to our local host and hit refresh, You can see we've got both getting to know IO.js and a better pull request deployed at the same time, which was the intent of the exercise.
Really cool.
Cool.
Great. So for folks who are on the line right now, we've got quite a number of viewers. Feel free to use that Q&A tool to ask us questions at any time. On to Ian Buchanan, who's at OOP 2015 in Munich. Tell us, Ian, how are things going out there?
Oh, sorry. As soon as I could find the mute button. Yes. Well, there's enough snow here to make me sympathetic to those in New England. So we're seeing some snow here too. Probably not as much. We're looking forward to having Sven talk about Atlassian coding culture tomorrow, and I'll be talking about the business value of Git on Thursday. So if you're in the area, pop by and see us. I spent the Monday tutorial building a domain-specific modeling language. It was really fun. This morning I listened to a talk about Agile fluency and just saw a talk about sociocracy, both very interesting things. Coming up are some additional talks about automated testing and continuous integration, continuous deployment, and all things Agile. So, well, in any case, you know, if you're interested in any of those topics, I'll be blogging about some of those quite soon. At the booth, I've been having some fun discussions about how Bamboo is better than Jenkins, or how Bamboo can be used with Android. Both some things I've been looking into lately. I'm also yeah. So anyway, if you're listening from Munich, drop by the booth and have a chat. Yeah, I think that's pretty much what's going on here.
What's the most popular question you're getting right now over there?
Well, it's really a class of questions about Bamboo, and I think that's mostly because other folks at the booth feel like Bamboo is very technical, and okay, all those questions go to Ian. But among them, you know, just kind of like what Bamboo is and you know, how it works and where it fits into the development lifecycle. Mostly, I think if people get interested in it, they know what continuous integration is, but are just really looking for product differences.
Super. Well, make sure to tackle Ian with your toughest questions at the OOP conference if you're there. Thanks, Ian. Steve, you're going to be coming out to San Francisco soon for Developer Week. Tell us about that.
Yeah. Hi everyone. So I'm going to be at Developer Week in about 2 weeks' time. So what I'm going to be giving is a tutorial / workshop on Docker. So the background to this came about when Nicola, who you might be able to guess is sitting next to me, has been giving a lot of talks about Docker for developers. But I've noticed that when talking to developers, there's still a lot of confusion about exactly what Docker is and how you would use it and why you would even want to use it, especially if you're not an operations person. So what I've done is I'm in the process of putting together, and I was actually testing this out with Nicola and some of the developers here in Amsterdam today. Was a bit of a tutorial about the background to Docker, about how it fits together, some of the underlying technologies about it, and then an example project that will use Docker to do some testing. It's got the project I'm going to be testing has some complexities around testing, which is to do with you have to use real Postgres and real Elasticsearch to do some real-time testing. So what we do is we use all the technologies and the concepts we learn in the Docker background session to build up a set of Docker containers that we can use to test our tricky little application. And then we go through some more stages of simplifying it and using some of the higher level tools like Fig to simplify it and eventually integrate it into a continuous deployment pipeline with using Bamboo. So now it's an hour session. There's quite a lot being packed in there. Hopefully we'll get through all of it. However, I will be hanging around for the entire week of Developer Week. So hopefully I'll be able to have some conversations with anyone who's really interested in learning a little bit more about this. This is kind of exciting stuff. It's a very new area and it's changing rapidly. I'm trying to sort of and hopefully introduce some people to some of the core concepts to help them sort of reason through the rapidly changing landscape of the Docker and the general container ecosystem. There's also going to be code shipped with this. Code is already out there. I think, Grace, if you can probably paste the link to it, which should be on our EAC, our Confluence page. There's code that you can sort of follow along with, or if you just want to follow along afterwards, or use the slides as a little workbook, then hopefully that will be of use as well. So that's going to be on the 9th of February, I believe, a Monday. So if you're at Developer Week, come along. Either come along to the session or just come and see me, and we'll have a chat.
Super. Thank you, Steve. Nicola just posted a link for that. Thank you, Nicola. All right, so moving right along, Tim, you had an interesting blog post on Bitbucket pull requests last week. You want to talk about that a bit?
Yeah, for sure, absolutely. So this is kind of an interesting post because it's a feature that's actually been in both Bitbucket and Stash since their inception. So we're kind of talking about a few years. But we realized recently that people may not realize that it's actually a feature. And what I'm talking about here is how Bitbucket and Stash do their pull request diffs. So I might just open the article so I can show you a couple of images from it. Let me just share my screen. Okay, so when you think about a diff in terms of Git, quite often you're just thinking about the changes that have occurred on a particular branch. You know, if you say you were doing a pull request the old way, so back before you had a GUI like Bitbucket or GitHub or GitLab or Stash, and you just pulled a branch down from a server and you wanted to see what had changed. Now you might think using this git diff triple dot syntax to see the changes on that branch is a reasonable way to do it. And this does actually show you the changes that have occurred on that particular branch. But in terms of a pull request, which is actually, it's not just a diff, right? It's actually the intent of, or someone's intent to merge some changes from one branch into another. This doesn't quite show the full picture. So the way we decided to implement pull request diffs in Stash and Bitbucket is to actually show you the difference between the two branch heads. And the reason we do that is because if you just look at the changes that have occurred on the branch that you're merging into your target branch, it's actually going to be missing any changes that have occurred on that master branch since then. And you might be wondering why this is a problem. And I was actually explaining this to my wife when we were walking the dog yesterday, and I was trying to think of a nice, approachable way to explain why this diffing algorithm can be problematic, or why you need to actually look at the changes on the master branch as well. And the analogy I came up with is, imagine you have two different developers working on a cookbook. And say you've got 3 recipes in that cookbook. One of them is a recipe for some pizza dough, and then that's already been ostensibly completed. And then these other 2 chefs are writing recipes that will be contributed elsewhere in the book. Say maybe one's writing a recipe for some calzone, and then the other one's writing a recipe for some pasta. Now, while they're working on their individual recipes and they're working on individual branches because they're using branch-based development, one of the chefs realizes that the pizza dough recipe is missing salt, and that's something you obviously have to have in your pizza dough. So they go and update the pizza dough recipe and say, okay, look, you need 2 tablespoons of Himalayan rock salt, and then they commit that on their feature branch, which contains this other recipe. But at the same time, this other chef, I'll use the term chef, is working on their own recipe. They also realize that that recipe is missing salt. So on their separate feature branch, they make a similar change where they add 2 tablespoons of sea salt to the recipe. So on each of their individual branches, the recipe is now complete, or the recipe for pizza dough is now complete at least. But they've made slightly different changes. One of them said, okay, we need Himalayan rock salt, and the other one said, okay, hey, we need sea salt. Now the problem comes when you merge these branches together, because when they complete their own individual recipe and merge that back into master, it's going to add 2 tablespoons of salt to this pizza dough recipe. But when the second chef also merges their own recipe into master, it's going to add an additional 2 tablespoons of salt to this pizza dough recipe, and you're going to end up with 4 tablespoons of salt and a super salty pizza recipe. So that's why it's important to show the changes on master as part of the diff. The reason being that when they create that, when one of the chefs when the second chef creates a pull request from their recipe branch back into master, they're going to see in the diff that there's already 2 tablespoons of salt there. Now, it does seem kind of maybe a drawn-out analogy. I highly recommend reading the article if you're curious about it. I'll just post that into the blog, into the chat window. But the other reason there is another reason why we show this type of diff as well. The way that we calculate this diff is actually by creating a fake merge commit in the background. So there isn't any simple command you can run in Git to see this kind of diff that shows you all of the changes on both branches. What we actually need to do is every time you update your feature branch or you update your master branch, both Stash and Bitbucket create a merge commit behind the scenes. And then they show you the difference between master and that merge commit, which is basically illustrating all of the changes that are going to happen on your master branch when you hit that merge button in the pull request. And so it gives you kind of the most accurate diff you can have, because it's really showing you how your branch merge is going to affect master and affect the code that you're intending to ship to your customers. So that's really why we feel it's the best diff you can have. But the fact that we create this merge commit also gives us another advantage, because it means we can detect ahead of time if your branch is going to conflict, because obviously that merge commit is going to conflict. And this is really handy because it means that the way we handle this is we actually commit all of those conflict markers that get generated by the git merge command into that merge commit. And that means that when we show you the diff to the merge commit, we can actually show you if your pull request is going to conflict. And that means that you can discuss with the other developers on the pull request how you're going to resolve those merge conflicts. And since a merge conflict by its very nature is obviously going to involve more than one developer, we think that the pull request is the best place to discuss how you can resolve these merge conflicts. So yeah, that's basically it. It's as I mentioned before, it's a feature that's been there since the beginning of time, and massive kudos to the Bitbucket and Stash teams for coming up with this merge algorithm. All I really did was kind of show people how we've built something kind of awesome.
So the JIRA podcast created quite a bit of discussion online. Nicola, you made some observations about some of those comments and discussions.
Yeah, so on a few technical forums on this post, that sparked quite a heated debate, and it's one of those debates that have recurring themes, and it was very interesting to chime in and chat and discuss with other teams and other developers how they were dealing with this sort of thing. So a few of the comments I saw, and what was interesting to share them. One were recurring, and then maybe we can add our own opinion to it, and then also say what we think about it. For example, one comment that was I saw quite a few times throughout these conversations on Hacker News, for example, was, well, this is all very nice. In practice, we don't really notice this problem very much because we recommend to our developers to always rebase their feature branches before they open a pull request. So, and then this problem generally doesn't happen. And this makes sense. And I think it's a very fair assessment. If your team is relatively small, or maybe your code base doesn't move very fast, that's absolutely true. And so if you're just a few developers in a startup and you know what the other guys are working on, and there's only like a handful of branches working on at a time, that works perfectly. And it might even work perfectly even as the team grows. But when you scale these up to bigger projects where, yeah, there might be 5 branches every couple of hours popping up and things being merged as the tests are complete, yeah, you reach a threshold where just a matter of rebase might not be even enough to see the real state of your branch. So whenever you will merge it. So it's a matter of scale. So what Bitbucket and Stash do, they give you a very complete view of what's going to happen if you merge, regardless of your team size. So you can work around it and have a simpler model, but it's just like slightly more advanced, more complete solution that you get for free. So that was one of my comments. The other comment that I saw quite a bit, and there is this ongoing debate about how to handle the merge strategies, pull request merge strategies. And that is, yes, but we don't like using merges. We actually like to rebase branches and then squash all the commits in a feature branch up to until we only have one, and then merge that one. And that keeps the history of a project linear, very elegant and clean. And it's a way. So this debate actually is been ongoing for many years, and there's pros and cons to different approaches. And we personally prefer to have a complete view that preserves the context of a feature branch. So we're trying to encourage our developers to do explicit merges most of the times. But I can also understand in a way that the elegance of having a very clean linear history. And some big teams do that too. So I actually wrote an article about this very theme a while ago. It's called Pull Request Merge Strategies. If you go to developer.atlassian.com/blog, you'll be able to find it. So I don't know if or guys, if you had any other comments on the debate that was sparked on.
Oh, totally. It was yeah, it was fascinating to see the level of sophistication of the way that people merge things. Like it seemed like there were 3 or 4 different kind of hey, we use merge, we use auto squash, we use we always rebase before we create a pull request, and then sometimes rebase after we've created the pull request before merging. Yeah, it's really interesting to see the plethora of different merge strategies that people apply out there. I just noticed there's a question that just popped up in the little Q&A app in the Hangout. Which version of Stash supports the beta pull request? So actually, it's been there since the very first version of pull requests in Stash, which I think was Stash 2.0 from memory. So if you're using pull requests in Stash, you already have this diff. You don't need to upgrade.
Super. There's another question as well, Tim. So basically, you should only use the octopus strategy if you want to do a merge where you know that you won't have any conflicts?
That's right. Yeah, look, I should have mentioned before, if you want to give it a try, the little git merge distinct tool that I posted before is actually available via npm. So you can, if you have got Node installed locally in npm, you can install it and test it out locally. In terms of whether you should use it when you've got conflicts or not, really the git merge distinct adds sort of a layer on top of the octopus merge that allows you to define which branches you want to merge. You can still use an octopus merge strategy locally, even if you expect conflicts, and then resolve them locally. Like Git has no problems with that. It's just if you're running it in a continuous integration environment, that's when you're going to want to avoid merge conflicts. And the way that we do that at Atlassian with our developer blog is ensuring that only branches with distinct paths have been changed, and that's built into git merge distinct as well. In fact, that's something I should have mentioned before. That's where it actually gets the name. If it detects that the same path has been modified on multiple branches, then it'll ignore later branches. So that means that basically only changes to one particular file on one particular branch will be merged into that bundle. But look, I've just posted a link to the blog if you want to check it out and give it a try. I think that really with git merge distinct, it's only really useful for deploying changes to types of content that can't really logically conflict. So it works well for our blog because it's static content. It's basically a bunch of markdown files that get rendered into HTML, and they don't sort of interlink. But we wouldn't use this for something like a Java project where you have different class files calling into each other, because if you change the contract of one of those class files and then one branch and you change it again on another one, or you change something dependent on it on another branch, when you merge those things together, then you're going to have compilation errors. So you have to be a little bit careful about when you might use the octopus merge strategy for deployment, and typically static content is a good way to do that.
I see there's another question which I think is very interesting. Maybe we can talk about it. So from Sam, it says that it's unclear for him how to actually resolve merge conflicts, and if there's any resource that we would recommend on how to do it and how does that work. So maybe we can elaborate a little bit on it and give some pointers. So a merge conflict is a relatively common operation and a common thing that happens while when you're working with multiple branches and people modifying code at the same time, same lines at the same time. So the way that generally you get a conflict is whenever you update changes, you collect incoming changes from other branches, like you update your master, and or you try to include those changes in your own branches if you're rebasing your own local branch, or if you're trying to merge your feature branch onto master, and then there's a conflict. And so what Git does, it basically annotates. So the very basic way that Git does it is it stops the merge operation or the rebase operation, saying, hey, there's a conflict that I am not able to resolve by myself. And Git is very helpful. It will annotate the files. So both if you type git status, it will list the files that have changes both in the incoming branch that you're trying to merge and in your local one. And if you open those files, you will see those relatively unfamiliar signs that says, hey, this is how that specific line looks in your version, and that's how it looks in the other branch. And so one way to solve those merge conflicts is to do it manually, which I think to get familiar with how Git works is a good place to start, and you shouldn't get scared by those esoteric signs. And what those mean is when you see like greater than, it means, okay, that is the version that is incoming, and then you'll see how those specific lines look in the incoming for the incoming changes, and in the less than annotated set of lines are how those specific lines look in your local branch. And what you can do, you can just remove those placeholders and make the code, those lines, look exactly as you think they should look. If you need to discuss how things should be resolved, you can always contact a colleague. But in general, for say 90% of the conflicts, it's generally easy to understand how things should be merged. And then the next step, which might be confusing for people, is you need to tell Git that you have resolved the conflict on that file, and you do that by adding that file to the index, which is to type git add and the file name on which you have just resolved the conflict. So by typing git add and the file name that was conflicting, you're notifying Git that you have resolved that specific conflict. So you do that operation for all the files that were conflicting, and after that you can just go on and type git commit, and the merge operation or the rebase operation that was ongoing will resume. In case of rebase, you have to type git rebase -- continue so that it resumes. In the case of the merge, you can just type git commit, and then the merge will happen. That's like the manual way to do it. But we had an internal discussion about it just at our company and a while ago, where people were asking, how do you guys solve conflicts? So the problem of SAM is a problem that a lot of us have. And it's like, what's the most efficient way to solve conflicts? So we collected a few tips, and actually we plan to write about it fairly soon on our blog, so stay tuned for that. Very briefly, a few things that came up and might be useful is you can use, if you use IntelliJ IDEA, for example, and your platform is Java, that has a very solid merging capability, that IDE. Some people use an open source tool called Meld. Some people use just to look at the diffs using SourceTree, which is our native client for Mac and for Windows. And some people do it manually. So one thing you can do is go online, look for a tutorial on solving Git merges, and you'll get some of the flows, or try to use a visual client. Yes, as you see, Tim has just posted a link to our beloved SourceTree. And I don't know if Tim, you or guys, if Steve, you have anything to add. I would just wanted to give a brief overview about this, because a lot of people have troubles with solving conflicts.
Super, thanks, Nicola. Ian, I'm going to switch over to you in Unix here for a minute. I hear you recently had a nice lesson around Git in the new blogging process. You want to share some of that lesson with us?
Yeah, so I think it's, in a way, it's like this reverse situation of the octopus merge. The situation that I had is that I started with a branch where I created a lot of related blogs just to kind of get a feel for what might be a series, and try to cut them down into smaller posts. I was very disciplined about commits, so I made small changes to one file at a time. But by the end, I just wanted to pluck out the series of commits related to the one that was the most mature, ready to go out the door, and so I, okay, how should I do that? In the Get Right tour, we talk about rebase as replaying commits on another branch, or cherry pick. And so Tim and I kind of bounced a couple ideas around. I tried interactive rebase, but one of the drawbacks there is that interactive rebasing didn't just replay the commits that I was picking onto the target branch. It was actually recreating the branch that I was working on with all of the big commits and all of my content. So to back that out, I used the ref log and rearranged the pointer, something else we pointed out in the Get Right tour. So this was good reinforcement. And eventually just went back to cherry picking. It just took kind of a blog post that was out there about how Git rebase is defined in terms of Git cherry picking, plus some of the additional things that you would have to do with manipulating an intermediate branch just to kind of get the same effect as a rebase. And then that helped me understand where I was kind of losing the plot about rebase. So turned out all to work in the end with cherry pick, and I was particularly pleased with how easily I was able to do the cherry picking. So yeah, that's about it right there.
Super. Thanks, Ian. We've got a few more questions that have come in. Let's see here. What is the best form of deployment from staging to production? Would you have staging as you first stream and then have production as an upstream? Found that to be running into this issue lately. Anyone want to take that one?
So the way that we do it with the blog and some other teams at Atlassian, particularly for SaaS projects where we have kind of like one staging server and then our production server beyond that, is that staging is always a subset of the commits that are on production. So what we usually do is name our staging branch develop and name our production branch master, very similar to Git flow. And basically we promote changes through staging to master. The only thing about this particular way of working is that basically any changes that you have on develop should be intended to go through to master. So we try to make sure that our features are complete before we merge them in. And it's very rare that we sort of unmerge a branch from develop. So instead, we typically try to roll forward. So if we kind of merge a feature into develop and then there's issues with it, we'll create another feature branch and then fix that and get that fixed on staging before we promote to master and production. The actual mechanism that we use for that is typically where we can continuously deploying from both the develop branch and the master branch. So basically, as soon as you merge something into develop, that will get deployed to your staging server. And then as soon as you merge develop into master, that will get deployed through to your production server automatically using Bamboo. I don't know if you guys had anything to add to that.
One of the ways, the way we did it, my background on the previous team was almost the internal systems team, business platforms team, and we did a lot of continuous deployment. One thing we definitely tried to do was basically roll out onto staging, and then once we went through certain QA, human-based QA on staging, whatever was on staging got promoted up to master. So there was no real separate streams of development for staging and for production. What we would do would basically, when we were ready to go out, and what we were trying to move towards is basically every single branch merge, every single feature branch results in a release. So basically, this is like, it's called release by feature. And it gives you very fine-grained releases, but you have to be able to do continuous deployment and high availability to be able to pull this off. But the advantage is that you basically, every single thing you roll out is a single cohesive change, not a bunch of unrelated changes. So what we do is roll those out to staging, and then once we're happy with them on staging, they would get promoted directly up to master. There'd be no separate staging to master branch. Or when I say master, sorry, to production. So basically, you'd run the binaries through a complete set of automated tests, roll them straight out onto staging. Staging would go through human testing, and then whatever's on staging, if it was satisfactory, would get moved up to production.
Nice. Actually, I just saw there's a follow-up question from Stan, who asked the original question, saying, we commonly use cherry picking to redo changes to a new branch when the original branch was made off an incorrect branch. Look, that's totally fine. Another way to do that is to rebase your branch off, well, I mean, like if you accidentally branched off master and you wanted to branch off develop instead, you can rebase your changes with that, which is effectively a cherry pick. The other thing you can do is cherry pick a range of commits. I'm not sure if you're cherry picking individually or a range at the moment, but cherry pick actually supports the same range or commit specs as the git log or git diff commands. So you could actually say git cherry pick, the base of the branch dot dot the tip of the branch, and then it'll actually cherry pick all of those commits over to the new branch. Hope that helps.
Yes, I saw that. I was about to answer exactly the same question. What I was thinking is, yeah, there's no danger in copying commits around as long as you are, if the source, then it's not used. In reality, if you reapply exactly the same code change twice, what you'll get is a no-op. So there's relatively low risk. What is wrong about using cherry pick is, because you're randomly reapplying patches here and there, you lose track of where those changes come from. So that's the reason why we try to isolate and keep work in feature branches so that it's easy to track where do changes come from. But there are specific scenarios like the ones you mentioned that are absolutely acceptable. So.
Nicola, actually, while we have you on here, do you want to talk a little bit about your Docker Hub hack?
Yeah, sure. Yeah, so it was one fun hack I worked on a while ago. So every few months we do a hackathon here. So we call it Ship It Days, where like the company stops for 24 hours and groups are formed and we work on stuff that's cool and that could help us, our products, solve our own problems and improve tiny or big things at Atlassian. And so my idea was, hey, I'm very excited about Docker stuff. Can I do something relatively quick in 24 hours that can have like an interesting impact or interesting use? And using Docker, so I wanted to do something with Docker using Docker.
Congratulations.
Yeah, and so what I did, maybe I can share the page as I talk. So you can. There's an article about this on the blog, so it's called "Hacking the Docker Hub into Bitbucket." So Docker has a registry where you can prepackage your applications to run in containers, and it's registry.hub.docker.com, and there you can see the metadata and the amounts of downloads that a certain container, a certain packaged application has. And I thought, you can build containers from Bitbucket, but wouldn't it be nice if we could show actually that information in Bitbucket itself? So how many people have downloaded that container, if it is packageable as a Docker image. And so what I did is I asked friends in the Bitbucket team to open an iframe there, and I developed a small static website based on Nginx that would go to the Docker Hub and collect all those statistics and inject it inside Bitbucket. And that's rolled out and in production, so I managed to do that all in 24 hours. It's only limited as for Atlassian employees, so it's actually, you cannot go to Bitbucket and see it live, but I put a video of it, demoing it and showing that it's actually real, and you can do a live update of this platform just by using and starting containers. So I encourage you to have a look at the video, and I'll post the link, or maybe somebody, I'll post the link into the chat if you guys are interested. So I thought it was an interesting hack to show, and because we're very interested at Atlassian about new developments about Docker and how new trends of cloud-based deployments. So personally, very excited about it.
Awesome. Thank you, Nick, for sharing that with us. With that wraps up our content for this session of the DevDen Hangout. Thank you, everyone, for joining us. This is being recorded, so we'll be posting this recording shortly, so you can take a look at it again, and we'll have a transcript available for it in a few weeks. Thanks, everyone. Thanks, guys.
Thank
Have
you.
a good day.
Cool.
Bye.
Bye. Bye.